Hello, in this particular video we're going to simplify rational expressions, and we're going to start by factoring any polynomial that's given in this expression. The numerator, x minus 7, there's really not much you can do with that. That's already been factored, and the denominator is what we want to focus on. Okay, that is a binomial, and it's a difference of two perfect squares. Okay, so we can go ahead and factor that, all right? And when we do that, the numerator stays the same. And the difference of perfect squares, we can just go ahead and factor it directly, because 49 is a perfect square, so 7 times 7 goes there, and then x squared is a perfect square, so x times x goes there as well. And then all we just need is the signs. One's positive, one is negative. Okay? And notice that we have we can look at the numerator and we can actually rewrite it as minus 7 plus x. And that way it looks like the binomials in the denominator. Okay, and then we can factor out that negative, okay, or negative 1, and write it as 7 minus x. Oops. Okay, and when we do that, we can now cancel the 7 minus x's. Okay, so that cancels, and then you're just left with minus 1 in the numerator over 7 plus x in the denominator. Okay, or you can write it as negative 7 plus x. Okay, you can write the negative off to the side. Okay, so this one you had to rearrange one of the binomials to make it look like the ones on the bottom. Okay, so that you can cancel, because x minus 7 and 7 minus x are technically not quite the same. We have to factor out a negative 1 with the binomial in the numerator in order to make it look like the one in the denominator. So it's just something to keep in mind when you see a situation like that. You may have to rearrange it and factor out the negative. Okay, so let's do another example. Okay, and we have 16 minus 2x divided by 7x minus 56. All right, so here what we're going to do is, these are binomials, and we're going to see if we can have any GCFs that can be factored out. And if you look in the numerator, okay, we can factor out a GCF of 2. And then basically we say, well, 2 times what gives me 16? That's going to be 8. Minus, and then the x stays behind. And we can go ahead and do the same for the denominator. We're going to factor out a GCF of 7. And now the x stays behind, and then minus 8. Okay? And you notice that we're going to rearrange the numerator. Okay? I'll write it over here. We're going to rearrange that as minus x plus 8. I want it to look like the x minus 8 in the denominator. So what I'm going to do is I'm going to factor out that negative. Okay, so it's basically factor out that negative, and then basically that turns into an x minus 8. Because remember, when you factor out the negative, the x now becomes positive, and then the positive 8 now becomes negative. Okay, because you've got to be able to distribute back and see if you can get the original polynomial. So when you do a minus 1 times x, you get minus x. When you do minus 1 times negative 8, you get positive 8. So this is going to equal negative 2, because a 2 times a negative 1 is a negative 2. Everything else stays the same. Now we can cancel the x minus 8s. Okay? And then you're just left with sorry about that. Minus 2 over 7. And that would be your final answer for that one. Okay? So this was a good problem because you not only had to factor out the GCS, but you had to rearrange one of the binomials again in the numerator. All right? So let's go ahead and do another one. And here we have 5x cubed minus 40 3x squared plus 6x plus 12. All right. So we have some factoring to do. So what we're going to do is factor out the numerator, because that's a little bit easier. And we're going to take out a GCF of 5. And that's going to be the x cubed minus 8. All right. And then we're going to factor out the denominator. All right. So when we factor out the denominator, we should probably take out a GCF of, we have 3, 6, and 12. So the GCF, the biggest number that would divide into those three numbers would have to be 3. All right? And then you're just left with x squared plus 2x plus 4. Okay? Now you have a much simpler trinomial to factor. Okay? So, now the numerator, that's a difference of 2 perfect cubes. All right? So that means we're going to have to use the following formula for the perfect cubes. Okay? So here, I'm trying to think where I can write it. All right, so this part right here requires this formula, okay? So we're going to use this formula for x cubed minus e. And that's going to be a minus b times a squared, okay? Plus ab plus b squared. Okay? So we have to use that formula in order to do that. All right? Okay, so now remember, when we do the difference of perfect cubes, we have to take the cube root of the first term and the cube root of the second term. The first term is going to be a cubed. So when you take the cube root of that, that's just going to give you x. And when you take the cube root of 8, that's just going to give you 2. Okay? So we want to make sure we understand that. So, so over here, all right, when we take, we're going to let a equal the cube root of x cubed, and b equal the cube root of 8. Okay, well, we said the cube root of x cubed is x, and the cube root of 8 is 2. And that's what we need to plug in the numerator. So, okay, so we're going to write that over here, 5. Okay, and remember, we're going to plug everything in, okay, into this a minus b formula, a squared plus ab plus b squared. Remember, a is x, b is 2, so we're just going to substitute. So we're going to replace a with x minus b. B is going to be 2. And then we're going to replace a with x. So this is x squared plus AB, well, x times 2 is 2x, plus b squared, well, 2 squared is 4. That's what the numerator is going to look like when you substitute your a and b's into it. All right? Notice the 5 has been factored out. Don't forget the 5. Okay? And then off to the side, we'll factor this trinomial over here. All right? And so what we're going to do is, actually, I don't have to factor that out, because watch what happens. We can just cancel that, and right? And notice the denominator is 3 in parentheses x squared plus 2x plus 4, right? We don't have to go through all that trouble of factoring that trinomial, because I just realized that x squared plus 2x plus 4 in the numerator cancels out with the x squared plus 2x plus 4 in the denominator, and that makes life so much simpler. All right? So that's going to equal 5 times x minus 2 all over 3. Okay? Or that's equal to 5x minus 10 all over 3. Okay? So any one of these would work. Okay, so that one wasn't as bad as we thought it was, okay? We used the cancellation of the two trinomials of x squared plus 2x plus 4 to eliminate that, and then we're just left with everything else, okay? So I hope that this video helped you with the concept of simplifying rational expressions.